Okay, this is the last problem on page 177. It's in the margin. And it's talking about a core skill. It's talking about when do I graph, when do I substitute, and when do I eliminate. So let's read through it and see what we've got here. You have learned 3 methods to solve a system of equations: graphing, substitution, and elimination. When solving a system, you should try to choose the method that is most efficient for that particular system. If both equations are solved for y and the numbers are relatively small, graphing may be a good choice. If one of the equations, is solved for a variable or can easily be solved for a variable, substitution may be the best method. In all other cases, elimination may be best. For each system of equations, describe the solution method that would work best. So I'm going to pull these over to a sheet of paper, and we are actually going to solve them because I just want the practice of doing that. And I also want to talk to you about the best method. So let's go over to Functions Notebook and paste that in. Actually, I'm going to crop because I don't need all of that. I need the space more than I need that. So let me copy it, and then I'll crop this one so that we only have this system to look at. And let's go with that one first. So in this particular case, we have negative 5x plus 4y is 12. Okay, those are not small numbers, and it's certainly not solved for a variable. It's in standard form. And I'm going to write that down there for you. This is standard form. This is not standard. It's not anything that I recognize as a normal form. In this particular case, the best method is elimination. Because we have that single y, okay, we need it to match up with this y. We already have a positive 4. If I can get a negative 4 down here, we're in business. So that's how I'm going to approach this one, using the elimination method. So we have negative 5x plus 4y is 12. And down here I have 2x minus y is 5. So I'm going to work on this bottom equation, and I want to insert the negatives already there. I just want to put the 4 in. So we do that to both sides, and we will have to distribute right here. So we get 4 times 2, that's 8x, and then negative 4y is 20. So that is the rewriting of the equation. Now let's solve. So we have negative 5x plus 4y is 12. We didn't do anything to the top equation. Down here we have that negative 4y we wanted. So we can eliminate or cancel the y's. So I'm left with 3x equals 32. So divide by 3. And x would be 10 2/3. Let me be sure. Yes, 10 2/3. And I'm going to use the fraction because that's a repeating decimal. So you have your x value. And remember, the solution to a system is a point. So we have x. That's 10 2/3. But we need to get y. We only have half of the picture at this point. So pick one of your equations. I'm just going to use that 8x minus 4. Y is 20. And for x, I'm going to put in 10 2/3. Then minus 4y is 20. Now remember, they didn't tell me to solve these. That's why the fraction is so weird. But 10 2/3 times 8 is 85 1/3. The Casio will do it for you. So then I'll move the 85 1/3. And cancel it here. So I'm left with negative 4y equals, if I had thought through this, I would not have tried to solve it. But we're there, so let's go ahead. Negative 4 and negative 4. So y equals negative 16 1/3. That's the other half of this equation. Fractions are just numbers, guys. Don't let them rattle you. Use the calculator and you'll get there. So negative 16 1/3. Back in the dark ages when I first started teaching this, we didn't have calculators. They weren't allowed on the test. So we would have had to do all this by hand. It was not pleasant. Okay, let's put in the next example. So the first one was solved by elimination. This one, let me crop it. Sorry. Well, why won't it let me crop? There we go. This one. So let's study the form before we try to make a decision on what to do. Now, I notice first off that both of these are in slope-intercept form. This is a graphing problem. And I'm going to skip it for now because once I cut and copy that graph, I won't be able to get my equations in. Let me just go ahead and put the bottom equation in, and then I'll deal with that situation. So I want to crop this. I had a question about the app that I'm using here for this process. It is GoodNotes. If you have an iPad with a pencil, you need the GoodNotes app to be able to do what I'm doing here. All right, I need a graph for this one, so let me go back to page 1 and get that copied. And I'll go back to the page we're working on and paste this coordinate plane. So we need to graph both of these equations. Now, let's study them first before we just go hog wild and graph. This is y equals x plus 2. So this is slope. I can tell you by looking that slope is 1. 2 is the y-intercept. So it's going to be at 0, positive 2. So we can graph this just using that information. Let's go to 0, positive 2 and put a point. And remember, slope can be written as a fraction of 1 over 1. So we're going to graph using that. We would go up 1 over 1. Let me get it straight, or my graph will be all wonky. So up 1 over 1, up 1 over 1, up 1 over 1, one more, and then I'll put the other point. Okay? Then I can connect the dots to get the line. I need to see the line for this to work. So here comes the line. Ooh, that one's good. That makes me happy when it lands just perfectly. So this is the graph of y equals x plus 2. Let's go ahead and write that in there so we know which line we're talking about. All right, then we need to put the other line on the graph. I'm going to do that with green. So my equation is y equals negative x minus 1. So slope is negative 1. And we'll go ahead and write it in fraction form. And then the y-intercept is 0, negative 1. So this time I'm going to start at 0, negative 1. And slope is negative 1, 1. So we're going to drop 1. Let me do it this way. Here comes the staircase. It's drop 1, run 1. Drop 1, run 1. And let me put another point and draw the line. And I said I was going to do that one in green, but I'll just go ahead here. I've already started. So we're going to bring a line right up through here. And he didn't quite snap to. Let's try it again. This is much easier without the iPad, because then you have the straight edge. There we go. This is looking good. This one I'm going to bring on down just so I can show you clearly what I'm talking about. You've got it right here. Because remember, at the point they are intersecting, you have your solution. The point of intersection is your solution. And this looks like about, oh goodness, this is a mess. Back 1.5 and up 0.5. So that would be the solution. Wherever the two intersect is where your solution lies. This is an independent system because there is one solution. Okay, finally, we have this fella where we have one of them in slope-intercept. I don't like graphing on this one because the numbers are bigger. And then one of them in standard form. I would probably use elimination on this one, quite honestly, because the y's could be canceled easily. But they want us to use substitution. So in this one, we will do substitution. This is actually a good one to substitute because the one is already in slope-intercept form. You've already got it solved for y. So I'm going to take the standard one. And wherever I see a y, I'm going to substitute this quantity. Now I can do that because y equals this amount. So this amount is going to go in there for y. So I'll say 4x plus 2x plus 8, that's that value of y, equals 5. So I have 4x plus 2x plus 8 is 5. So 6x plus 8 is 5. Move the 8. Cancel. 6x is negative 3. So 6 divided on both sides gives me negative 1/2. That is the x part of the coordinate. Because remember, the solution to a system is a point. So we know the x is negative 1/2. Let's see what the y will be. And I think I'm going to just use that first equation because it's already set up for y. So y is 2 times negative 1/2, that's the x value, plus 8. So 2 times 1/2 is 1, and it's negative. So y is 7 for this point. That's the other half of the solution. You have to have them both to have the solution. So the answer to this one is right there. The answer to this one is right here. And the answer to this one is up here. We've already highlighted it. So there are a few more examples. Again, the point of this question was which method is best. So for the first scenario, the elimination method. For the second scenario, we used graphing. And for the last one, we used substitution. Okay, we are ready for the final review. I believe it's page 177. Let me just take a look here. Sorry, no, it's 178. That was 177 we were on. So I would encourage you to go to 178, try this review by yourself, and then come back and watch the explanation of the review. And that will give you a chance to sort of test yourself. So I will see you soon, and this is what we will be doing.